Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for happy number problem. Let's look at the problem description. We have to write an algorithm to determine if the number n is happy. The happy number is a number defined by the following process. Starting with any positive integer, replace the number by the sum of the squares of its digits. Repeat the process until the number equals 1, or it loops endlessly in a cycle which does not include 1. So those numbers which this process ends in 1 are happy. We have to return true if the number n is happy number, otherwise we have to return false. Let's take a look at the example 1. So the given number is n is 19. So the sum of the squares of its digits are 1 square plus 9 square is 82, and 8 square plus 2 square 68, 6 square plus 8 square 100, and 1 square plus 0 square plus 0 square equals 1. We reached 1, so this is a happy number, so we have to return true. The constraints for this problem are the value of n is ranging from 1 to 2 to the power 31 minus 1. Let's look at the approach to solve this problem. So we are given the input number, which is 2, and the expected output is false. Sum of the squares of its digits is 2 square 4, and 4 square 16. 1 square plus 6 square 37. So if we repeat this process, finally we reached 4, which is already seen. So again this will go in a loop, right? Basically we have to detect this loop. For that we can use the hash map. Okay, so each time we generate the number, we check whether that number is equal to 1. If that number is equal to 1, that means it is a happy number. We have to return true. Otherwise we have to check whether there is an entry for that number in the hash map. If there is an entry, that means there is a loop, so we can declare that number is not a happy number. Okay, for example, in this case it starts, we see the number 4 here. After few times we generate the number, at the end we see the number 4 again, right? So the same numbers will be generated again and again, so this will go in a loop. Okay, so when we see this number 4, at that time we check the hash map. There is an entry for that number present already, so that means there is a loop. So when we hit that condition, we can return false. Okay, so that's what I have written here. First we initialize a num map with an empty map of int to bool, and if the number has only one digit, that means single digit number, then we check whether the number is equal to 1. If that is true, we return true. Otherwise we check whether the number has an entry in the num map. If there is an entry, then we return false. Otherwise we add an entry for the current number in the num map. We repeat, then we compute the sum of the squares of each digit in the number, assign the sum to the number, and repeat the above steps. Let's look at the flowchart. Input for this procedure is a num integer. First we initialize the return value variable to false and initialize the single map with an empty map. Okay, then we check whether the number is less than 10. If that is true, then we check whether that number is equal to 1. If that is true, then we return true. Otherwise we check whether there is an entry in the single map for that number. If there is an entry, that means we are in a loop, so we return false. Otherwise, we add an entry for the current number in the map. And then we call the square sum function to compute the sum of the squares of each digits in that input number, and then update the num. And we repeat this process until we either see the number 1 or we detect the loop. Finally, we return the red valve. Let's move on to coding. First, I initialize the red valve variable to false, and then initialize the num map with empty map of into bool. Then I write the for loop. Here I check whether the number n is less than 10. If it is true, then I check whether that number is equal to 1. If it is true, then I set the red valve to true and then break out of the loop. Otherwise, I check whether there is an entry for that single digit number in the num map. If there is an entry, then I set the red valve to false and break out of the loop. That means there is a cycle. Otherwise, I add an entry for that new single digit number in the num map. Then in each iteration, I call the square sum function to compute the sum of the squares of the digits of the number n. Then I finally return the red valve. Next, I write the square sum function. First, I initialize the sum variable to 0, and then I write the for loop which runs as long as n is greater than 0. Then I compute the remainder by doing n modulo 10. And compute the square of the remainder and add it to the sum. Then I divide the n by 10 and assign that quotient to number n. Then I finally return the sum. Next, I'm going to run the test cases. All the tests passed. Next, I'm going to submit this program. Cool, this program is accepted. Next, I'm going to do the code walkthrough with sample input. So the input number is 7 and the expected output is true. First, we initialize the return value variable to false and then initialize the num map to empty map. Okay, and the input value n is 7 and the num map is empty. Okay, iteration 0, we check whether the number is less than 10. In this case, it is true. Then we check whether that number is equal to 1. It is not. Then we check whether there is an entry for that number in the num map, and there is no entry for that, so we add that number in the num map. So that's what. So there is no entry in the num map, so we add an entry for that number in the num map. So the num map has one entry. So after that, we call the square sum function which computes the sum of the squares of each digits in that number. So for this case, only one digit, so 7 square 49. Okay. So in the iteration 1, we check whether 49 is less than 10, that is false. So we call the square sum and update the value. In this case, it becomes 97, 4 square plus 9 square. So in the iteration 2 we have 97, that is greater than 10. So again we compute, we call the square sum and update the num. So 9 square plus 7 square, 130. Okay. And in the iteration 3, 130 is greater than 10. So we again call the square sum and update the value. So now we get 10. 1 square plus 3 square plus 0. So we get 10. And in the iteration 4, so 10 is, so the number n is equal to 10. So still this condition is false. So we go ahead and update the number by calling square sum function. So in this case 1 square plus 0 square, n becomes 1. Okay. And in the iteration 5 we check the n is less than 10. It is true this time. So and then we check whether n is equal to 1. In this case that is also true. So we set the return value to true and then break out of this loop, and then finally we return the red val. So the red val is true. That is an expected output. Next I'm going to do the time and space complexity analysis for this solution. Time complexity for this solution is order of log n, and basically the time complexity analysis is done in terms of the number of digits processed. For example, in this case the input number is 7. First we compute the sum of the squares of its digit. It becomes 49, 97, 130, 10, and then finally 1. Okay, so this series has 6 numbers. So 1 plus 2 plus 2 plus 3 plus 2. So totally 10 digits we processed. Okay, so we can get the number of digits in a given number by taking log on that number. So log n plus log n plus log n. It's kind of tricky because if we say n, we think the original number, but the transformed number, it's kind of tricky. So basically assuming this series has m numbers. Okay, so in that case it will be a order of m log n. I actually try to compute how many numbers are generated for a given input number with a single digit, and in that single digits the maximum value is 9. So for this number, so the series has 18 numbers. For the given input number with value 99, the series has 20 numbers, and for 9999 it's 16. So for the largest number, for the largest input number, the total number of elements in the series is 18. Okay, so in this 20 is the maximum number of possible numbers that can be present in the series. Okay, so if we add that, replace m by 20, then we can remove that constant factor 20 out, and then we get order of log n. And the space complexity for this solution is order of 1, because we are allocating space only for the single digit number. So because of this condition, the num map will contain only the single digit number. Okay, and then the input constraints, the problem constraint says the value starting from 1, right? So and also the 1 is a happy number, so we can exclude that. So the remaining 2 to 9, only for these 8 numbers we need to allocate space in the hash map. So that is constant. Regardless of the input numbers value, we need maximum 8 entries. So the space complexity is order of 1. Thanks for watching this video. Have a great day.